I timestamped this video, so if you want to skip ahead right to the deriving section, you can do that. But in the meantime, I wanted to actually talk about the steps and foundation of what's to come later. So just remember that completing the square is actually a geometric technique. So we're literally going to be sketching like squares and rectangles. So, and then, one of the steps of completing the square is adding things to both sides. So I just wanted to go over the foundation stuff, as I said. Feel free to skip ahead. Okay, so I just have a random equation here, 2x minus 3 equals 9. So obviously, if we were to solve for x, right, we would have to add 3, and then 9 plus 3 is 12, and then dividing by 2, we would get x equals 6, right? So now what happens if we're going to pick any number you want? It doesn't matter how big or small, could be a million, could be 100, could be 1, doesn't matter, right? And then what we're going to do is take the same equation, we're going to add the same number to both sides. So how about 7, right? So let's say we pick the number 7 and we're going to add it to both sides of the equation. And now we're going to solve for x. Let's see what happens, right? So before we do anything, let's combine like terms. So that's going to be 2x, and then negative 3 plus 7 is plus 4. And then combining like terms on that right side, 9 plus 7 is 16, right? So now we have this quote unquote new equation. Let's see what happens, right? So we're going to subtract 4 on both sides. Surprise, surprise, we get 2x is equal to 12, right? That's the same scenario as we got up there. So then dividing both sides by 2, we get the same answer. Is it just with the number 7? What if, let's say, I picked another random number, how about 11? But make sure you have to add it to both sides, right? So now what happens when we combine like terms here, we get 2x plus 8, and then 9 plus 11, that's going to be 20. So now we have this quote unquote new equation. So that way, when we subtract both sides by 8, we get 2x is equal to, surprise, surprise again, 12, right? Divide by 2, we get the same answer. So there's a theorem that whenever you add, as long as you add the same exact number to both sides, right? If you add it just to one side, then it changes the answer. As long as you change it to both sides, it'll actually not change the answer as we saw before, right? So later in completing the square steps, one of those steps is going to be, we're going to take this magic number and we're going to add it to both sides. And so now already we've set the stage for that actually is not going to change the answer, but there is a reasoning to do all that. So I'll explain everything in this video. Okay. So the next thing we got to talk about, because we're going to be drawing squares and rectangles later, talking about area and things like that. Let's just kind of do like a precursor, right? So number 2 here says we're going to draw a square with area x squared, right? So a square is where all 4 sides are equal, right? So the area is the side length of the square squared, right? That's the area, A's area. So that would mean that you could just label it as X, or if you want, you can label all 4 of them X, doesn't matter. Or if you want to think of it kind of like a rectangle where it's length times width or whatever, right? X times X is X squared. So we're going to, again, draw that later in our completing the square derivation. So now we're going to draw a rectangle with area 6 times X, right? So does it matter whether I label this 6 and this X, or could I have labeled maybe this X and this 6? Either one of these are correct, right? As long as you're able to recognize that, again, it's the area is length times width, right? So it's not very specific. We don't know which one is which, but just to get the gist of it. Okay, and then 2 more, and then finally we'll get to the actual derivation or deriving completing square. So in the rectangle, what is the value of y? So just knowing the fact that opposite sides of a rectangle are congruent, in other words, are equal to each other. So if this is 7, then that means that y is equal to 7, right? And if this is equal to 6, then this is equal to 6. Right, and then it's asking what is the area of the rectangle? Again, it's length times width. So the area A is 6 times 7, so it would be 42. I just realized I got cut off there. So what is the expression that represents the area of the big rectangle? That's what it means to say. I don't know why I got cut off there. So As you can see, we have this is a square and then this is a rectangle, right? So if the side length, so this is where we kind of put everything all together, right? So if the pink is the square, all lengths of a square are equal to each other, right? So that's x, and that is x. And then a rectangle, right? Opposite sides are equal to each other. So this would have to be 5, right? And this would have to be x. So later on, again, we're going to be labeling all 4 sides. So what expression can represent the area of the big rectangle, right? So now it's just referring to this big rectangle here, right? Okay, so it's this big one, right? So how can we represent the area? So again, the area is length times width, right? If this is the width and this is the length, how can we express the length, right? That could be expressed as x and then plus 5, right? And then this is x. So we can express the area as x, that's the width, times the length, which is x plus 5, right? So we can write it this way, or later when we derive completing the square, we're actually going to simplify that. In other words, we're going to distribute, all right? So another way you could say it is x times x is x squared, and then x times 5 is 5x. Okay, so both of those are fine. One's in factored form, the other one's in standard form. So now we have everything we need to actually go ahead and do the derivation. So again, I left a link below. This is actually worksheets with step-by-step answer keys. I just posted this on YouTube, but if you want the actual physical copy, you're more than welcome to grab that. All right, so here we go. We're going to finally complete the square. So it says begin with a square with area as x squared. So we worked on that before, right? It's not a coincidence that I asked those similar questions. So if we have a square, right? And it does say make sure to label all 4 sides. So again, this would represent the square with the area x squared, right? We talked about that below. So check. Now we're going to add to the right side of this square a rectangle with area 6x. We went over that before, how to draw a rectangle with area 6x. So we're going to add to it on the right side. So maybe something like this, right? So how could we do area 6x? It would have to be length times width, right? So 6 times x is 6x. But again, right, opposite sides are congruent. So if this is x, then this has to be x, right? And in order for it to be an area of 6x, that would have to mean that this length here is 6, okay? So we just labeled all 4 sides. Step 2, check. Now, how can we represent this as an expression for the total area of the large rectangle? So again, this is similar to this last problem we did, number 5, right? So we're going to look at it the same way. So the total area of now this large rectangle here, right? If this is the width, how do we express the length? That's going to be x plus 6. So the area, or the total area, is going to be x times x plus 6, but we want to write it in simplest form, so we're just going to use the distributive property. So that is equal to x times x, which is x squared, and then x times 6, so that would be plus 6x. So far, we have sketched a big rectangle in blue with an area of x squared plus 6x, okay? That's where we're at. So now, what are we going to do? Step 4, right? So this is check. So step 4 is now we're going to cut the small rectangle, the one with the area of 6x. So we're going to cut that guy in half, right? So now what will the new area be? So after we got the area of the rectangle, which is 6x, we cut it in half. So in other words, we're dividing by 2. What would be the area of that smaller rectangle, right? That half rectangle. Well, 6x divided by 2 is 3x, okay? So now, it then says to erase, in step 5, right? It says to erase the rectangle with area of 6x. So let's go back up here. So again, this is the rectangle with area 6x. And what we did was we cut it in half, right? So now there's two separate rectangles with each of them as area of 3x, right? Half of 6x. So the next step is, as it said, we're going to erase that area of 6x, okay? So let's do that. So we're going to take this and completely erase this, right? So the next thing it says is now we're going to add to the right side of the square the new rectangle dimensions that we got from step 4, right? This was step 4. So now we're going to the right of it, instead, sketch a rectangle with area of 3x, right? So how would we sketch a rectangle with area 3x? Right? So again, opposite sides of a rectangle have to be equal. So if this is x, then for it to be an area of 3x, we would have to label those two sides as 3, right? But again, we don't want to actually change the total area, right? So that's why the next step, so underneath the square, we're going to add to it another rectangle with those same 3x dimensions, right? So remember we took the rectangle 6x, we cut it in half. So it's overall going to be the same area. So now underneath it, right, is going to be the other rectangle with area 3x. So again, we didn't actually change the area, right? Because we cut it in half. So if this is x, opposite sides are equal. So that has to be x. For it to be an area of 3x, that means that those two sides are 3, right? So again, we did not change. So again, this asks, in doing all of this, did we actually change the area of the total area? No, right? So we cut it in half, but think of it as puzzle pieces that we just moved the other half down below, right? So again, this is in my worksheet if you want it, link below. So in step 6, so now we have a scenario where it's like a puzzle, right? Now we're missing a square piece. And what we want to do is we want to create one big square as a final picture. So let's take a look at what's going on. So we want, right? So let me actually go here, right? So this right here is a missing piece, right? What we are trying to do is complete this square. So how do we complete the square, right? The entire picture, I want one big square. We need to complete it. So in other words, we're asking ourselves, well, what's the area of that green square, right? So we can get the big completed square picture. So how do we know, first of all, that it is a square? Because this is a 3 by 3, right? If this length is 3 and this length is 3, there's a square, right? So that would mean, right? So if you thought it was a rectangle, right? If this is 3, then this is 3, opposite sides, right? And if this is 3, then this is 3, right? So we can see that this is actually a square. So what is the area of this green square? Well, that would be, right? So let me go back to green. So this area right here is 3 squared, which is 9. Okay, so we did step 6. So now we actually already did step 7, right? We used our spatial skills to find the area of that small missing square piece. So the area we found was 9, right? So we just completed the square. If we, like a puzzle, inserted an area 9 square, we have now had a scenario where we completed the square, right? So what is now the total area of this big square? The hint is you can actually just take your answer, right? Remember that we were previously working with an area of x squared plus 6x. So we just now added to it an area of 9. So that is now the expression that represents the area of the completed square, right? And how do we know, by the way, that it is a square, right? How do we know that this, as I said, is a square? Because notice this length is x plus 3, right? This length is x plus 3. this, right? So all of those four sides are lengths x plus 3. So we did, in fact, create one big blue square. It's pretty cool. So now we have this what's called a standard form, right? Quadratic expression. We're now going to factor this expression using the AC method. And if you forgot the AC method, I'll put a link down below on how to factor the polynomials, specifically the AC method one. But I went over also factoring all of the polynomial. All right, so factoring the AC method, right? So we're looking, so the AC method, let me actually back up, is only, you can only use it if the degree is 2, so the highest exponent is 2, and it's a trinomial, so there's 3 terms, right? So that's the only time we can attempt the AC method. So A is the coefficient of the x squared term, so that's 1. B is the coefficient of the x term, so that's positive 6. And C is the constant, it doesn't have an x attached to it, which is 9. So why is it called the A times C method? Because you're actually going to multiply A times C. So 1 times 9 is 9, right? So the AC method is the factors of A times C, and we're looking for the factors that add up to B. So specifically in this case, we're looking to do a factor tree of A times C. In this case, it's 9, right? So that's a positive times a positive, or a negative times a negative, right? So this is the complete list of factors. So which one of those adds up to B? That's going to be these guys, right? 3 plus 3. So now the beauty of whenever you have a equals 1 problem, there's actually a shortcut. And that shortcut, only when A equals 1, is the template is always 2 parentheses next to each other, and both of them have an x to it. And now all you have to do is take those factors and plug it in. Since both of those are positive, I'm going to write plus 3 and then plus 3. So there we go. We just factored it. And if you don't believe me, I'm not going to do that here. But if you were to do the distributive property or FOILed, whatever you do, and you simplify it, you would get back the original. Okay. So now what's really interesting is what's another way that we could write x plus 3 times x plus 3? Well, I can write that as x plus 3 squared, right? So squaring something, that's what it means, is to multiply something by itself twice. So that would have to mean this right here is called a perfect square trinomial. It's a perfect square trinomial because it's trinomial, right? It's 3 terms, and it can be also represented as a perfect square. So now you have to ask yourself, shoot, do I actually have to do the AC method every time? No. So part of the completing the square step is actually there's a template that you could do to just get it from here to here, okay? You don't have to do the AC method. So how do we know what to add by? There's this magic number that we're going to talk about in just a second. Okay. So let's make some connections here. So again, we have a quadratic trinomial, right? Standard form ax squared plus bx plus c. So let's make some connections, and then we can actually derive the completing the square steps. So we just found that the total area of the completed square was x squared plus 6x plus 9. So if we identify a, b, and c, right? We did that before. A was 1. B was 6, and C was 9. So we'll keep that in mind later. So remember right over here in this step, we took the rectangle 6x, the area, and we cut it in half, okay? So that was the rectangle 6x. So if we take a look here, that was the B value, and we cut it in half, okay? So how can we use the same idea to make the connection between how we started from the number 6? How do we get, in other words, how do we go from 6 to 9, right? So no adding 3, I mean, yes, adding 3 to 6 is 9, but again, how do we use what we just did, right? So remember, step 1 was we took the 6 and cut it in half, right? Which we got 3. And then the second thing we did, remember then we had that missing square piece. We found that square piece as 3 squared because it was an area of a square. So that's how we started with a B value of 6 and ended up with that completed square of 9. So again, if you remember, one of the steps from completing the square is we cut b in half. And then the second step is to take that answer and we squared it. That's where it comes from. In general, how can we represent the area of the small missing square? So if we have in general, right, x squared plus bx, what would be that area of the small missing piece? So just like we did in the previous example, in general, you take b, you cut it in half, and then you take that answer and you square it. So this will always, in general, be the area of that small missing square that we have to complete in order to make that big square, okay? The other connection that's also in the steps of completing the square is how can we represent that total area in factored form, right? Remember before we had this standard form perfect square trinomial, and then we used the AC method and we factored it to this, remember that? Well, you don't have to do the AC method. So again, there's actually going to be like a template. So that template is, it's always going to be x plus something squared, okay? Always. So how do you know what goes in the box? What goes in the box is always going to be half of b, right? Remember, this number had to be 3 here. So in other words, b was 6. 6 divided by 2, or half of 6, is 3, right? So we can see how it all works. So the good news is, a good way you remember it is how to factor it is always going to be the first step of when we completed the square, okay? So remember the very first thing in our warm up, we were able to add any number to both sides. The very first thing we looked at was in B and C, right? Remember, we took an equation, we added 7, we got the same answer. And then we took that equation and added 11, we got the same answer. So again, we talked about that as long as you add the same exact number to both sides, you're not actually changing the value. So, so we're going to keep that in mind, right? So that's going to be one of the steps in completing the square. So here it is. Here's the reference sheet. Again, I left that link in the description. So, or you can take a picture of it as you're looking at this, right? So here's the actual completing the square. So first things first, the very first step is you have to make sure that the leading coefficient A is +1, right? Because remember, in the previous example, we started with an area of x squared plus 6x. Remember that a was 1. So that's the only way that it works. So in this example here, notice that a is 2. So if a is not 1, you have to just divide everything by whatever a is. So in this case, we divided everything by 2. So you have to make a equals 1. So notice over here in our example, there was no c value, right? Because we then have to take we then just took half of the rectangle 6x, we cut it in half. So before we can even do all that, that constant c can't be there. So step 2 would have to be, you have to move c to the other side, right? So again, in this specific example, we would have to move 4 to the other side. So we have to just do the opposite operation, right? So we get x squared minus 8x equals 4. And notice that I left here a blank space, right? And by the way, I left a link in the description, also my other YouTube video where I actually work through completing the square example. So I'll leave that in the link, right? So now what goes in that blank spot, this is where then the next step was, right? So visually, we knew to cut b in half and then square it. So keep in mind, this will always be a positive number that you're adding, because then squaring a number is always going to be positive. Otherwise, it's wrong, right? So in this particular case, b is -8, right? So when we cut that in half, that's going to be -4, right? And then you have to square it. And -4 times a -4 is +16. So remember that as long as you're adding the same number to both sides, again, we have not changed the answer to this at all whatsoever. But why the heck would we want to go through all that work is, again, so now what happens is when we add 16 to both sides, this right here turns into what's called a perfect square trinomial. So if you want to knock yourself out, factor it using the AC method, you can, or remember that template that template that I talked about before is always x plus something squared. So what is that something is always half of b, right? So again, b here was -8, and then when we cut it in half was -4. So that's why here we see this -4. So all of this work, so now we started with something that was in standard form, and we just converted it without actually changing the answer to get it in this form, right? And so how did we get 20, by the way? We have to simplify the right side, 4 plus 16. So now, finally, and I'm not going to go through all this in detail because I showed you in another video, then the last step is we can finally use the square root method to solve for x, right? So over here, it's showing you take the square root of both sides, the squared cancels out. Always make sure to put the plus and the minus symbol, right? And then from there, you can solve for x. I hope this was really helpful. So again, I left all the links, even to my blogs, everything below if you need to look at that. I also put a link to my course if you're a student, and I have everything from modules, obviously chapter lessons and homeworks and quizzes and things like that. So you're more than welcome to sign up for that. And you can also take a look at my other related videos that I also posted a link in the description. Don't forget to subscribe and make sure you can leave a comment below if you have any questions or if you have any suggestions for a future video. And I hope to see you soon.